Alright, hi guys. This is Mrs. Goswish, AP Chemistry teacher, and this is part 2 of the Empirical Molecular Formula section in Chapter 3, Stoichiometry. This is Section 7, and this is the second part. This is calculating the molecular formula. Alright, determining the molecular formula. We need the empirical formula. Now you're going to get the empirical formula one of two ways. Either you've done the problem from the start and you have already figured out the empirical formula from the multi-step problem, or it is actually given to you in the problem. Those are the very simplest problems. They just say, here's the empirical formula, here's the mass, da 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 da. So the second one is like the super simple ones, which you're not going to come across much. Because of course in AP Chemistry we prefer the more multi-step, harder problems. The molar mass of the molecular formula will also be given to you typically in the problem. Please don't panic. This is going to be either molar mass or molecular mass, so not only could they call it molar mass, but they might refer to it as the molecular mass too, same thing. Please remember the molecular formula can be the same as the empirical formula. This occurs if the ratio is 1 to 1. And the molecular formula can be a multiple of the empirical formula. First step, obtain the empirical formula. Again, you are going to be obtaining the empirical formula either by doing a multi-step problem and getting it yourself, that was from part 1, or the very simple problem is they give you the empirical formula in the problem. Compute the empirical mass from the empirical formula in step 1, which is the same. If it's CH2, 1 carbon, 2 hydrogens, add them up, there's your empirical mass. Calculate the ratio of the molecular mass to the empirical mass. I call this the Me equation because it is technically the Me ratio. Molecular or molar to empirical mass. This number is always going to be the larger of the two, and I refer to it as the Me equation. Take the integer from step 3 and multiply the subscripts of the empirical formula to compute the molecular formula. And the molecular formula can be a multiple of, or if the ratio comes out to be 1, then the empirical and the molecular formula are going to be identical. So we're going to do an example. This is very easy. This is a problem that gives you the empirical formula, and it gives you the molar mass, or again, this could also be referred to as the molecular mass. And we are going to just figure out the molecular formula of this problem. So a couple of things I'm going to write down. I'm going to write down what's given in the problem. They give me the empirical formula of CH5N. The empirical formula's mass is 1 carbon, 5 hydrogens, and a nitrogen. Add them up, and that's 31.07 grams per mole. The way to calculate the ratio or the integer for the molecular formula is given to you a couple of slides back. I call it the Me equation. That's the molecular or molar mass divided by the empirical, and the molar mass is given to you in the problem. The empirical I just figured out above, and I get an integer of 1.9936, which is of course 2. So the last part, the molecular formula, then will be 2 times whatever the empirical formula is, which is going to be 2 times CH5N and that is going to be C2H10N2, and that's a very simple problem to do. Not so simple because you have to go through the steps of figuring out the empirical formula on your own. So they give you a substance that's analyzed, found to be phosphorus and oxygen atoms in the compound, gives you the molar mass of the compound, and they want you to do both steps. We're going to determine the empirical formula and the molecular formula. So I'm going to do empirical formula first. Follow the steps from part 1. I have a compound, and my job is to find the subscripts. I have phosphorus and oxygen, and it tells me 43.64%, so 43.64%, assume 100 grams. I am dealing with 43.64 grams. 56.36 grams of oxygen. Step number 1, done. Step number 2, divide by molar mass. And oxygen is 16.00. Get the moles of. These are in moles, so here's my step number 2. Here's my step number 1. They were given to me in a problem. Please remember that the combustion problem is the hardest one to do for empirical formula. This is not a combustion problem. This is simply a percent by mass. Step number 3, take the smallest number here in step number 2 and divide all of them by it. You will always get one of them to be a 1. This comes out to be a 1, and this guy comes out to be 2.5. So here's my step number 3. You will notice in this particular problem I have to do the 4th step. I need these numbers to be whole. I can't have it as 2.5. That's illogical. So some number times 2.5 will give me a whole number, and of course that number is 2. So I multiply both of them by 2, and I get 2 and 5. So my empirical formula is going to be P2O5. That means my empirical mass is 141.94 grams per mole. In order to find the molecular formula, I use the Me equation. It is a ratio of molar or molecular mass to empirical, and the molecular mass is always given to you in the problem. The empirical I just figured out, and this also gives me a ratio of 2 to 1. Therefore my molecular formula is 2 times the empirical, and I get O10. So pretty easy.